Alright, so we are in the last section of Unit 1. Who's ready to be done with Unit 1? Actually, Unit 1 is kind of nice. I like it. Nice and easy. Hopefully you like it too. So there's going to be some reviewing this as well. We're going to start with inequalities. So all that's going to change for that is your equal sign will now become an inequality, which is not equal, which is less than or greater than. Or we can have the equal bar. So just to kind of see where we're going, look at this. X is greater than or equal to 8. We are going to plot these on paper on number lines. Okay, so you will see number lines. But I want to keep in mind you still can put this in your graphing calculator. Okay, so just to show you real quick, X is greater than or equal to 8. I'm going to put that in Desmos. X, and then greater than or equal to is right here, and then 8. Just to show you what it looks like, and it should look like this. Yes, it looks like this also on your graphing calculator. So what it's doing is it's having your solid line, and it has a solid line because we have the equal bar. If we change this to a regular greater than sign, whoops, then the line becomes dashed. Okay, so let's change it back to that. Alright, so that's solid and dashed. And then everything is shaded, since it's a greater than symbol, everything greater than 8 is shaded that way. Now, since there is no y, we're really just using the number line, okay? So whenever you need, like if we type in an equation and you want the answer, you'll see a similar thing. You'll see a line, solid or dotted, and then you'll see shading left. Or if this was a less than sign, it would be shaded to the left. So it'd be shaded this way or this way, and so you just compare, oh, where's my number at? Oh, it's at 8, so the answer's 8 type thing. Alright, we'll do a little bit more with that when we get there, but I just wanted to show you, you can put these on the graph, you can graph them, put them in the calculator, which is nice. So when we are graphing inequalities, similar to the solid line and dashed line, we use dots on the number line, and I'm sure you've done this before. If it's a closed dot or filled in dot, it will be for your equal bars, so less than or equal to, greater than or equal to symbols. If the dot is an open circle, ooh, sorry, kind of ugly. Anyway, so that is how we're going to graph these on a number line. So this is a filled in dot, so they left the numbers off, so that way you can just put your answer straight in the middle. And then, of course, shade to the right because it's greater than. So I'm sure you remember that. All right, interval notation. So this is probably something you either forgot or maybe you have not seen before. So interval notation, it's like a shortcut way to write your answers as opposed to the graphing. So or in addition to the graphing. So you might have to write your answer a special way. Interval notation is a special way. So it'll be using infinity symbols, parentheses, brackets, and of course your numbers. It'll kind of look like a coordinate. The parentheses, they will indicate when the value is not included or open circle. The bracket will be used when it is included or closed. Okay, so in other words, the symbols for open are that and that, and the symbols for closed are that and that. Okay, so to write this in interval notation, you always start left to right. So work left to right. Okay, the left of your graph is where you start, and you first look for what's the first thing you come to. And the first thing we come to in this problem is the dot at 8. So we're going to have, like I said, it looks like a coordinate. We're going to have the 8, and then we have to decide, based on the dot, is it an open parentheses or is it a closed bracket? And it is closed, so we will put a bracket. So bracket 8, comma, and then what's happening after that 8? The infinity. Okay, so you'll put infinity, you could put infinity first if this was flipped. If this was shaded this way, you'd start with negative infinity and then do 8. Okay, but since we work left to right, the first thing we come to on the left of my graph is my number. Okay, so these could be, it doesn't matter what position the number's in, just it has to follow the answer. Alright, so let's do number 2. And oh, by the way, infinities always get parentheses. We should probably note that somewhere. Did they say that anywhere? No. Let's note that. Infinity or negative infinity always gets the parentheses. Alright, so A is, and this is your less than, okay, looks like an L, but it's tilted in a little bit, so I'm going to fill it in with a, not a closed circle, open circle, because I'm not an equal bar, no equal bar, and then put -1, and since I'm less than, which direction will be less than? That would be this way. Interval notation, you work left to right, so the first thing I come to is infinity, but since I'm coming from the left, that's negative infinity. Okay, this is indicating that my answers go forever to the negative direction. In this side, it was forever to the positive direction. Then I put my number that it stops at, and then I finish it with a, since it's open, I finish it with a parentheses. Okay, so you can have a mixture, whatever mixture of parentheses or brackets that you need. Okay. Alright, and that is interval notation, so we will be using that quite a lot. Alright, now for solving inequalities, very similar to what we did last section, solving for equations. Follow the same rules as you would an equation. One additional thing to note is you will have to switch the inequality symbol if you multiply or divide by a negative number. Hopefully you remember that. I know you've been taught that. Alright, let's see. Do we have an example of switching on the first page? Looks like number 6 might be. Let's go ahead and do number 6. Since that might be the one thing we forgot how to do or about. So 3. So again, this is where my equals normally would be, but I do everything the same as far as simplifying everything out. So -4m and then -1. And then I have like terms. I have a 3 and I have a -1 over here. So 3 minus 1 is 2. 2 minus 4m. Alright, now I want my m's on the same side, so let's add 4m. Keeps everything positive. Isn't that what we're supposed to do in this life? Keep everything positive? Be positive. Positive is better than negative. That's what the world needs. More love. Or kindness, or whatever. Yeah, that good stuff. Alright, now we're, oh, it ended up not working. Did it work out? 27 equal to 9m. Let's see, did I make any mistakes here? No, yeah, it happened to be the way that I did it. The sign, or everything flipped the way it's supposed to. 27 divided by 9 is 3. And then 3 is greater than or equal to m. So no, we didn't have to flip the sign in this one. I was anticipating we might have to, but it's not a big deal. So plot your 3 with the closed dot. And m is now, don't forget, this can be switched, but the little tail, the small end, is your lesser end. So m, or all the numbers that are less than 3, would go this way. So that's to help you shade. So the little tail is facing the smaller number, and the mouth is eating the bigger number. So the mouth is eating the 3, meaning 3 is the biggest number. Alright, and then for interval notation, we work left to right. We start with, all this is filled in, so that's negative infinity. and then it stops at 3, and it's filled in, so it's a bracket. Okay, alright, so why don't you try the rest of these problems on your own before you see the answers. Just a heads up, there will be some different answers like fractions, decimals, and just keep an eye out that if you're multiplying or dividing by a negative number that you switch that inequality sign. So if it was a greater than sign, switch to a less than sign, and vice versa. And you also may get some kind of weird solutions. I'll just say that. Alright, so go ahead and do 3 through 12, and again, you don't have to do every single problem if you feel like, oh, this stuff is so easy. You just do half of them. And then I would definitely try to do the difficult ones, the ones that appear the most difficult, just to make sure you can do those right, okay? So, press pause and then play whenever you are ready to see. Alright. So here's your solutions. Number 3, 9 is greater than V, or V is less than 9. It's the same thing. So we shade to the left, open circle, and there should be a 9 there. My bad. Negative infinity, comma, 9, both with parentheses. This one came out to be a fraction. X is greater than or equal to 17 over 3. Solid dot here, since it's greater than, or since it's equal to, it's solid, shading this way because it's greater than. So we get a bracket, and then 17 over 3, comma, positive infinity with a parentheses. Number 5 comes out to P is greater than negative 7.5. So open circle at negative 7.5, shading to the right, giving you negative 7.5, comma, infinity with both parentheses. Number 6 we already did. Alright, next page. Number 7. 7 I went ahead and worked out to show you that. Make sure that, yes, this is what you get. Negative 27 is greater than 4. That is a false statement. So, you know, it was easy with the equal sign to see, oh, they're not equal. But now it's like, okay, this could be a true statement or a false statement. In this case, we get a false statement, so no solution. Okay, if there's no solution, you don't have to graph, you don't have to do interval notation. 8 was A is greater than or equal to 3.5 with this graph and interval notation. Number 9 was R is greater than or equal to 1 with this graph and interval notation. Number 10, P is less than 0. So open circle at 0, shading to the left, negative infinity, comma, 0. Number 11, another one that came out different. So the x's went away. We ended up with this statement. Negative 4 less than or equal to negative 3. Negative 4 is less than negative 3. So since this is true, our solution is all real numbers, so you can shade the entire number line. And then for interval notation, we're coming from negative infinity and ending at positive infinity. So you can do that when you get all real numbers. And then number 12. This is one that came out to be a switcheroo. So you multiply both sides by negative 2 to start out of the gate, and that means we have to flip that sign. So flip that bad boy around. Then there is no other place where we have to worry about that. So for the rest of the way, we end up W greater than 8/3. So open circle for 8/3. W is greater than it, so we shade this way. Starting our interval notation, we have an open circle, so that's a parenthesis, 8/3. And then it continues to positive infinity. Alright, hopefully you did pretty well. Alright, set notation is another type of notation. Okay, to express the inequality, set notation always has these squiggly brackets. Okay, that's wide across the math world. That's what it is. Set notation is your fancy brackets. Okay. And you see it look like this, X, such that, so this bar, and we're going to write that down below here, such that x is greater than 5. And then we close with the back end of the fancy bracket. So we read this as, so I'm going to write out how we say this. Oh, I already messed up. So set is whatever's here in front of your bracket. That's what the set part is. The set of whatever variable. The set of x values. Such that, and that's what that is. So this means such that x is greater than 5. Alright. Let's see what we got coming up next. So I believe we're going to use that type of notation. Yeah, we will use that in the future. Okay. Alright, so that's just another type of notation with interval notation. Alright. Now we're going to do a little bit more with inequalities, but there are cases where we can have compound inequalities. In other words, there are two parts or multiple parts to the inequality. So we're going to fill that in, 2 or more inequalities. And I'm sure you've seen those before where you can shade both directions on your number line from two different numbers. Two or more inequalities graphed together on the same number line. Like this example right here, we have everything less than -4 equal to and less than -4, everything greater than 1 from what it looks like. So if we write it in set notation, we would say, all right, x such that x is less than or equal to -4. And then this is an or statement when we have two different directions. Or x is greater than 1. And then we close the bracket. In interval notation, we start from the left and work our way right. Okay, so from the left we're coming from -infinity and stopping at, so we want to, yes, we do want to stop. Even though it continues that way, we don't just say -infinity to +infinity, because we have this set group right here that we have to eliminate. So I'm going to show you how to eliminate that. -4. And then, so it's going to be two parts. One, oh, that is not supposed to be a bracket. That is supposed to be a parenthesis. So from 1 to +infinity. Okay, then here in the middle, what we're going to do is say, so this group and this group are both part of the answers, so we unite them with a U. So this symbol, U, is called means union. So these are two answers together. Okay. Alright, so to solve these type of inequalities, and what do they look like? Yeah, they look kind of different. Physically, they have the word or there, so you are given two completely separate problems. So what you have to do is solve for each part, and then just graph each part on the same number line. So, seems pretty easy enough, right? Nothing too tricky there. You just have to do two equations instead of one. So let's say we minus 4, giving you 3x is less than or equal to 6 divided by 3. X is less than or equal to 2. Yes, yes. Divided by 5. X is greater than 9, and there's your two answers. So, to graph, we want a solid dot at 2, shaded less than, and then we want an open dot at 9, shaded greater than, so to the right. So there's your values, 2 and 9, just to kind of cover them up. Or just, if you want to put that, just in case it's like a little bit hard to read, go for it. Interval notation, negative infinity, and then you get to 2, and then it's a solid circle, so you do a bracket, union with 9 to positive infinity. Alright. So, what do you think? Not too bad? Hopefully it's not too bad. Alright. I think I can let you practice a little bit. Let me see. Those problems look good. Yeah, go ahead and practice up to number 6. Okay? Alright. Pause the video and then press play when you're ready. Alright, here are your solutions. Number 2. X is less than or equal to negative 1 and 4, and not equal to 4. So, bracket here, parenthesis here. Alright, number 3, y is greater than or equal to 5, and y is less than or equal to negative 3. So, negative 3 this way, 5 this way, both have brackets. Number 4, a is greater than negative 1 and a is less than negative 6. So open at 6, less than, open at negative 1, greater than, giving parentheses all the way through on this interval notation. Number 5, k is greater than 4.5 and k is less than or equal to 0. So solid at 0, going to the left, open at 4.5 to the right. Yes, it would be a good idea to go ahead and write 4.5 since that's not actually a mark on the graph. Bracket at 0, parenthesis at 4.5. And number 6, negative 7 and 4. You are closed at negative 7, shaded to the left, and open at 4, shaded to the right. And here's your interval notation. Alright. Now, those were our OR statements. If we have AND statements, we want to know where they happen at the same time. So it's either, in the previous ones, your ORs are indicating that your answer is either in this range or this range. AND changes it up a little bit. As you can see on this example, we have shading in one section instead of 2 sections. So this will be written as, let's see if we can write this out, x such that x is, now with this we can really combine it into one. So I'm going to do that. I'm going to say, alright, I have x is in the middle, right? X is greater than negative 2, and it's also equal because it's filled in, so x is greater than or equal to negative 2, but x is less than or equal to, oh, not equal. There's an open circle there. At 5. So that'd be the fastest way to write it, with x in the middle like that. So, and then your interval notation is with the parentheses, so, and brackets. So starting with, we have nothing until negative 2. So not as many infinities in this one. So bracket, negative 2, okay, all the way to 5. 5 is not filled in, and boom, there you go. So not too bad. Because the solutions to an AND inequality fall between 2 endpoints, they're more condensed, which I just said. Oh, they already did what, they're just explaining what I already did. So if you have 2 AND equations and on the graph they happen to overlap, you can do that. Okay. Alright, solving them. So again, they have the word and in there, but really the trickiest part is going to be the graphing part. So let's go ahead. Let's see if there's a weird one. I don't think any of them. Let's just do 11, I guess. 11 looks like it just might have a little bit something in it. Some weirdness. Oh, yeah. Oh, okay. I see. But they started with and. Okay. They started doing two separate ones, but then they combined them into one. So we did a little bit of this in geometry. So you have 3 sections: first, middle, and then your third section. So 3 sections. That just means you want to isolate the variable, which is usually in the center section. So the first thing we would do to get m by itself is to get rid of this into -2. So we're going to add 2. When we do that to all 3 parts. 28 plus 2 is 30. I added, so I don't have to switch signs. That's what I was kind of wondering, if I have to switch signs in this one, which I am on the next step. -7 plus 2 is -5. Alright, I have a negative number, so I'm dividing by -10. That means my signs are going to switch. Alright. So 30 divided by -10 is 3, but -3. And then switch my sign. I'm going to go ahead and switch the other one before I forget. This will cancel out, leaving m. This one will simplify to 1/2. Let me see if I got that right. Yeah. Oh, we are good. So, since m is between these two and my signs are facing less than, then I can graph it just like that. -3, I have an open circle. 1/2, 1 and then 1/2. I have a closed circle. M is between them. Then you're good. Okay? So what I'm opposing this to is saying if I had 1/2, if all my signs are like this, I just have to switch everything around. Okay? But this is still the same thing as this. Okay, but in this case you wouldn't want to write out, it wouldn't be in order, it'd be backwards. Okay, so if all your signs are less than, it's just a little bit easier to graph it. Let's look at interval notation. So I have a parenthesis at -3, comma, 1/2, and then a bracket. So there's the interval notation. Alright, I don't think there's anything else too strange. So they all the graphs will look like that. They'll have a center shaded section. So go ahead and try the rest of these and press play when you are ready to see the answers. Hello. Alright, our answers are back up at number 7, parenthesis, -6 to 4 parentheses. So parentheses on both, open circles. Number 8, parenthesis at -8, comma, 5, and then a bracket. Number 9 starts at -1 with a bracket, and then to 7 with a bracket or filled in circle. Number 10, 0 to 5, but not equal to 0 or 5, so parentheses, 0, comma, 5. And number 12, I went ahead and showed the work to show that you have to flip your signs twice. So we have -2, when we multiply both sides, or all 3 sides, by -2, that was negative, so we flip our signs. Then when we come down, we have -x left. The only way to get that by itself is to divide by -1. Then that's dividing by a negative again, so then you flip the signs again, putting it back to the original way. So leaving you with 2 less than or equal to x, which is less than 8, bracket 2, comma, 8, parentheses. So there you go. All right. So now you're brushed up a little bit on your interval notation, inequalities, set notation, and all that good stuff. So this is actually the end of the first unit. I know there's another section showing up down there, but that's going to be saved for later. So, all right, see you next time.